First. This is hub to spoke and then spoke to spoke. First a hub and a spoke, then the spokes will talk directly. Okay? My topology, same. Internet, R2. Let's make it R1, R3, and R4. What we have done until now is created static tunnels with this guy, SVTIs with this guy. We'll do the same right now. We'll create the same tunnels with this guy as well as this guy from here and here. But we'll do it in a way so that when the spokes have to talk to each other, they create a DVTI. Right, change finally. They create a DVTI. If I have another spoke here, create a DVTI, and even between these. So different DVTIs. This will be one between R3 and R5, one between these two, one between these two. Virtual tunnels between different VTIs. Okay? This point here, is it going to be a VTY or a SVTY? This point. This will be a DVTI. Because one guy is not the only one who will create a tunnel with him. Many different will. So the same like we did right now, a DVTI. But the one different thing here is now this, I'm going to have a different color tunnel. These are static tunnels. Right? From down SVTIs, from up DVTIs. But I'll have to make all of them part of same group, which is done by network ID command. Why? If they are not part of the same group, they will not be able to share information of NHRP. That is important in this hub and spoke topology. The other thing is NHRP is not supported on pure IPsec. This is going to be a MGRE kind of a setup. So I will never do tunnel mode IPsec IPv4. I will always be doing an MGRE, which is a default mode. Tunnel protection will definitely be there with the tunnel protection. Okay? GRE is not Cisco proprietary. GRE is open. IPsec is Cisco. IPsec profile, the one which we create crypto IPsec, that is Cisco. It's also a part of everything else, but this thing that we are doing is Cisco. Flex is Cisco's. IPsec as a suite is not Cisco's. The implementation is Cisco's. With GRE mode is open, yes. GRE mode as a whole is an open standard. Okay? Done. Let's do this. Clear this all. Close this. And don't need this now. We'll do some policies before the break and some after. First things first. I need to push down my pool. In DMVPN we don't do it, but here I'm gonna do it. Why? Because I need to have similarities between DMVPN and server hub. Server hub and server client and hub and spoke. So the similarities will be that both will be providing the pool down. But at that time you need a username or password. Here you don't need one. Here you just need a tunnel from that side to here. Okay? Let's do this. First things first. Authorize the network to use the parameters for policies locally. How? A new model, a authorization network. I can use Muni, but I said for this, for NHRP to work, it has to be default. Okay. 2. Configure the default crypto IKE v2 policy so that it pushes down a pool of addresses. And also install a static route to the local on the remote client. For this step, I'll make this step 3. Step 2 will be create a local pool that will be sent down to the clients. IP local pool flex pool 10 100. What is the crypto policy? Crypto IKE v2, no, crypto authorization policy, crypto IKE v3 authorization policy, call it anything, IKE pol, route set, interface, and pool. The only difference between this and the last one that we did was this one will push down a pool. He will also push down that static route, plus he will push down that pool one by one. First 11, 10, then 11, then 12, then 13. Okay, let's copy this, paste it here on R1. Done. Everything is okay for now, until now. What is the other thing? The other thing you know from the back of your head. What is it? Proposal, prop, encryption, 3 touch, integrity, MD, 5, and group 2. Then speak up. Proposal is prop. Crypto IKE v2 keyring KR. Peer is any address .0. This is the hub. The hub, anyone can come in, right? Shared key. Done. What was the second part? Crypto IKE v2 profile IKE prof match identity remote address 0000 authentication local authentication remote pre-share, then keyring local KR. Always forget the then virtual template. Why virtual template? This is a DVTI on this side, right? And finally AAA authorization group. I'm using ESK. List is default which is pointing to the local, and the username is default, which is pointing to the policy.
Sir, but we created policy with other name.
Ah, that is a mistake. If I did that, I should create the policy with the name of, good thing, should be default. Okay, should be default. Done? This is the same thing I did before. The only thing I did was choose a default here and push a pull down to the users who are going to come up. Okay, done? What is the next step? This was 4. 5. Create the IPsec, specify the IPsec parameters to be used for child IPsec transform set preset ESP 3des ESP MD5. Create the IPsec profile. Create the IPsec profile, which calls the transform set and the IC profile that points to the local group. Author's authorization. Okay. What is the command? Crypto IPsec transform set. No, sorry, not transform set. IPsec profile. I prof set transform set T set I v2 profile I. Good until now? Is it the name? Yes, iProf. Let's copy this from the proposal and paste it. Nothing new that I'm doing. You have done this before. There is nothing new. That is the best thing about Flex. That is the beauty of it. The only thing, one thing I added was that pool. Everything else is the same. So if you know one, you know all. Right? And one thing I need to do right now, the last thing is create the virtual template, which will give out the pool as well as be used for hub to spoke communication. What was the virtual template number I used? 10. Interface virtual template 10. Do not forget the I did not create the loopback. I need to create it. It's the same concept. Why? Right? The same concept the last time. Loopback and call it IPM numbered loopback 11. Tunnel source 12.1. Tunnel protection IPsec IPsec profile I prof. No tunnel mode. Why? Because I'll be using network ID 10 and no, not in this one. It chooses it by itself. You don't need to do MGRE in this case. Okay. This, why do I need this? For the spoke to spoke communication. So he'll tell the spokes, hey, listen, go direct. Okay. Let's see if this works. Yeah. Am I missing something? Which one? I equation 2. The profile. Let's see. I'm calling the profile here. That is done in crypto maps. Set IKV2 profile. Here we do it inside this profile. This calls, check here, IKV2 profile. So this should work. Okay, it's up. It's up. So my server side is done forever. This is all I had to do on the server side. Everything is done on the server side. Okay, I just need to go to the client side to do the other stuff. I'll run routing protocol also. From the client, I'll just run a spoke to spoke tunnel, a spoke to hub tunnel right now. Spoke to spoke we'll do after the break. The policies that I need on the client, let's check those out. Or we can call it spoke. Let's go. Do I need this? I will use it. Why? To set my route set interface command, so that he gets a static routes to me. Not for the pool. I do not require the pool. So no pool. I need this, but only until here. Only until here. Then proposal, yes. Policy, yes. Keyring, yes. What about the address on the keyring?
क्योंकि अब तो बताएंगे
But आगे DVTI भी करेंगे. We'll use a DVTI also. For those we'll use the same policies. For every pair you'll have to do a different key then. That'll be a little too complicated. Because whichever pair, whichever spoke you have, you'll have to create a separate key here as well as do it here. Match identity remote address. You'll have to create that many entries in there.
So
You can do it 0-0. Whoever comes in and has the same key is fine. Whoever comes in to me with any source with this key, I'll accept him. You can do it separate, but in that case you'll have to create one for the server and one for each client. A keyring for him, a keyring for him, a keyring for him, a keyring for him. On that side also you'll have to create a keyring for him, a keyring for him, a keyring for him. You understand what I'm saying? Because it's spoke to spoke communication. And for each spoke you will have a different virtual access created. Okay? So no need this. Do I need this? Also the same? Same. Virtual template. Huh? Right now I don't need one. But right now I need this. Right? And this is the same. This will be different. So until here it's the same except for one thing which I'll change from here. The only one thing is I don't need a virtual template right now because I'll create the straight one going up. And this is the same because the default one says push that interface down. My parameters are same, my transform set profile is the same. The seventh step will be create a static tunnel pointing to the interface tunnel 0. IP address. What is the address here going to be? He will get it from the other side. The hub is going to provide him. But I'll have to put an IP address here. Negotiate it. Negotiate the IP address from the other side. This is the only one difference I'm doing on the client. Everything else was the same. Except I did not need a virtual template. I will need it later. But right now I'm just doing hub to spoke. So right now I don't need one. IP address, negotiated. Tunnel source. 192.1.23.3. Tunnel destination. Tunnel protection. And IP and HRP. Network ID should be the same. IP and HRP shortcut. But here, with the shortcut, no, not NHS. With the shortcut, I'll have to tell him where to take that shortcut from. Where to take that shortcut from? I'll have to tell him take that shortcut from a virtual template which I'll create on you. The name of that template is going to be 10.
So what about tunnel mode?
No need tunnel mode because I'm not going to create a pure IPsec tunnel. I'm going to leave it as a default tunnel. I'm not doing MGRE also here. Why? I'm creating a straight GRE tunnel up and I'm creating a straight GRE tunnel up. I'm not doing MGRE. It's not a multi-point tunnel on that side. It's not one interface connected to a lot of interfaces. It's separate tunnels. GRE tunnel here, GRE tunnel here. Okay, but a normal pure IPsec does not support NHRP. What supports NHRP is GRE. So that's why I have GRE tunnels. I don't need a mapping on the other side because I'm doing it through this tunnel 0 interface with the source and destination right here. This shortcut is basically when he gets a redirect saying go here, he needs to create a virtual access to go to the other side. That virtual access will be cloned from where? So take the redirect, take the shortcut using this. So create your virtual access based on this virtual template, which I'll configure after this. You do not require an NHS. His mappings will not be solved by here. His mappings will not be solved here. The hub will do it automatically. You'll see how. I'll explain how NHRP works in this. You do not need an NHS to solve your mappings. Why? Because it's not an MGRE. This is not an MGRE. It's a normal hub is in the middle and then you have two people going through. You'll see when you run routing protocols on it, the hub will automatically decide how to do the mappings. He'll just send redirects. He's only capable of sending redirects. But when these people receive the redirects, where do they go through? Through these virtual templates, which I just created.
In case of routing protocol, we have to mention the multicast.
We don't need to. We don't need to. Why? Because in that case, remember, it was an MGRE tunnel. So he did not know what the other side is. Here it's a point to point. All these tunnels are point to point, separate tunnels. By default, it's a GRE tunnel. I'm not changing the mode. There, remember, to do spoke to spoke, we didn't create a separate virtual tunnel.
Yeah, we have one tunnel.
You have a mapping done. He required the destination map, the destination address, source and source address, public address, and then he created the header and then he threw out. Here it's not the case. Here he will create a virtual interface between my side and the other side. We'll see that when we create the tunnel interface. You'll see what source and destination he uses. For right now, we'll just create this and see does it get the address from the hub. At least that should happen right now. Did I do anything in here? I did not copy anything, right? Copied nothing. Copy. Just checking everything is alright. Child, this, and this. So copy. Done. ICCamp is on. Tunnel is up. The tunnel has not got any IP address. So we need to fix that. Where's my pool? Flex pool using the I am not supposed to use the IPOL. I'm supposed to use the default. So this is crypto IKE v2 authorization policy.
You can we can check whether it's using
Which one?
that also.
See, it says this will modify the original IKE v2 policy. He was using iQual because I did not configure
But in default, you can change the last default and put like for it.
Yeah, but I told you it will not work where? It will not work when the NHRP is done. Right now he is using that. If we check right now, he should be using default because that's what I did. Remember, I changed it down here, right here. He's using default. So default has no pool that he gives out. I need to set that pool. Route set interface and pool is clear crypto sessions. This is a GRE tunnel, so I need to shut and no shut. That was IPsec. So when I do clear sessions, IPsec takes it down and brings it back up again. This is a GRE one, so it does not care about IPsec. No address still. Oh, we got an address. We have an address. How did this address come into play? The policy from there pushed it down to me. Show IP route. I have a static route towards whom? Who set this static route? The route set interface on that side. Does that mean R1 should also have a static route? Towards whom?
11 words.
Towards 11. So this guy is reachable to me. Who? Is reachable to me. If I run a routing protocol through it, should work. Should work, right? Do I have a? I don't have a loopback. R1 should have a loopback 10.3. I also create another one on R1. R3 should have a right here. Good enough? Good enough? So I can go to, what is the difference between the last one and this one? There's only one difference right now. Right now. I've not done anything else. It's just the pool. This address, in the previous one, for tunnel 0, I said IP address this. Here I said IP address negotiated. And I went to the server, I said pool. So he pushed that pool down. Until now, everything else is the same. The difference will lie with the DVTI that I'm going to create now. And you'll see how simple it is going to be. The only one thing with that is the concept, which I will explain to you after the DVTI is formed. How the NHRP mappings take place. Okay, I have done this. Same thing, I'll do it on R4. I don't have to do anything. All I have to do is change the source 24.4. Everything else is the same. Nothing else. Go to 4 and paste. .2. Router EIGRP 10. Who's my one guy? The hub is the only neighbor I have. The hub is the only neighbor that I have. And the hub will have how many virtual accesses now? 1 and 2. What have I created until now before we go on the break? Until now, what we have done is this. Until now, this is R2, the internet, R1, the hub, R3, R4. Always mess R4 up. Okay, so we have, what we have done is created a tunnel, DVTI here, created that tunnel right here, one this way, one this way. This end is 12, this is 11. This side is SVTI. This side is, but it's all happening on GRE. Why? Because I'm using NHRP. Right now there is no mappings. No one has done any mappings until now. We did not require a mapping. Why? Because these were created dynamically. He received this address from that guy, inserted the static route from this side, he inserted a static route for 1.1 from this side. This guy did the same. Right now we did not do anything to NHRP. NHRP will be used now when this guy will want to go. He will basically be using this source. So this guy will require a VTI. A DVTI. He will require a DVTI. But he will not require a tunnel source and a tunnel destination. That is going to be provided by NHRP. The source as well as the destination will be provided by whom? And we'll see how. NHRP will provide that. Okay? Let's take a break.
Sir, this,
Yeah.
the pool is downloaded to this R3 and R4.
R3 and R4, yes.
So how is it allocating the same IP address of the pool to R3 and R4? Because it is downloaded on R3.
This pool is downloaded to this interface of IP. He says interface channel 0 IP address negotiated. For that negotiation, he asks him, hey, give me an address. Does this policy allow him to give an address? Yes, it does. His policy says route set, right, and the pool. So he gives them an address. He uses that address as his IP address source.
Just set the pool on that.
Whoever asks you for the pool. So the tunnel is asking for the pool, give him the pool. This tunnel is asking for the pool, give him the pool.
IP of that pool is given to the interface.
Which this?
Yes, 111 and 12. Because pool is getting downloaded.
See, this is the pool. From the pool, one at a time. How does NAT pool give out IP addresses, dynamic pool? You have a whole pool. How does DHCP give out addresses? First he gives 10, then he gives 11, then he gives 12, then he gives 13, right?
But command which we give over here
Yeah.
is to just download the pool.
To download the pool. To whoever asks him.
Whoever asks, whoever negotiates, give him the pool.
Give him the pool.
But address, where are they specified?
It's specified here. See?
Address is negotiate.
No, here. Check this guy. Right here. Wait, let me remove this.
This is the pool.
This is the pool we have specified, and we have said pool for authorization policy sending, right? And we have called this authorization policy where? In IKE profile. This IKE profile I'll called where? In virtual template. So whoever asks this virtual template for a pool, he will go for his iProf to check for his policies. iProf will give him transform set and this. Transform set is okay, then he needs to check the iProf. He goes to his iProf. iProf is right here. iProf says authorization list is default. Goes to the default list, which is right here. Default list says give him a pool. And take the IP out of this pool and give it to him. The pool is here, right?
Yes, yes. I understood the pool is downloaded.
Yeah.
But from the same pool, he is getting the address.
From this pool.
Yes.
Where would I don't understand your question. Where would he get it from then?
Yes, means I was thinking that the pool is downloaded. Okay, the command was for downloading the pool on.
One of the addresses from the pool, not the whole pool. Oh, you mean this? You mean he is downloading the whole pool here?
Yes.
He's not downloading the whole pool. Pool flex means one address from the pool. It does not mean just push down the whole pool down. No.
Okay.
Just give him an address from the pool. That is that one address, 12. So he gives him 12. The other guy comes, he gives him 13.
Because after this, they will be communicating to hub again for the pool.
For who? Which
For
guy?
DVTI again they would.
No, they don't need a pool now. See, he has an address. Where's this guy? Okay, I don't have the thing. See, R3 has a pool address. What is it? 12.
12,
R4 has 13.
11,
11 and 12. When they want to communicate, they will require a source and destination. Which one do you think they'll use? They have 12 and 13.
Okay, using that only they would directly.
Using that only they will directly.
I thought that it is.
Every time he will get a pool. No.
DVTI for this.
No, not like that. He will not use a pool there. He will use the same source and
Virtual template
talk.
over there would have.
The source will be 12
12.
and the source will be 11 and they will communicate to each other. Okay, we'll do that after the break.
The break after.
Video pause किया मैंने I think. No, I don't think so. Alright, let's move forward. What am I supposed to do now? I'm supposed to create that virtual interface. Virtual interface that will guide my DVTIs between the spokes. I do not need a source and destination, which will be provided to me with the NHRP resolution request and reply. I only need to provide which shortcut to take in that also. Okay, so I'll go in here. I have created this tunnel which takes me up. I also need to create a virtual template. I believe I have something here which I put in. No, I did not. I did not do anything here. So I'll have to first go inside my profile and say virtual, name it 10. So interface virtual template 10, type, no source and destination, tunnel protection, IPsec, profile, prof, IP NHRP, network ID first is 10, IP address. Check this out. I'll do this here. What is the IP that I'll use on this virtual interface? Where's my this? I have R3, I have R4. Told you I always mess up the 4. This and R1. The address that he got from this tunnel was 11 and the one which he got was 12. Right? This is already an address that he has received. To create this virtual interface with this guy, he needs an IP address. Does it make sense to get another IP from the pool and then create a tunnel? Does not make sense. It makes sense if he uses this to do the tunnel on this side. Now I could say IP address this guy, but as you know, this is going to be a virtual access. Virtual access only works if you have IP unnumbered. So my address here, my IP unnumbered, what is it going to be? Exactly. It's going to be IP unnumbered tunnel 0. This address will be given to the tunnel using negotiated. So the address that comes here will be used for this virtual access on the other side. Right? And finally, I will also have to say that IP and HRP shortcut will be done using my same interface, virtual template, the same interface 10. That's what I did here also. I'm telling the tunnel that your shortcut is going to be through the template. But I also have to guide the tunnel, hey, listen to the shortcut. I'm guiding this tunnel to listen to the shortcut. I also have to guide this tunnel to listen to the shortcut. Right? And the interface is going to be himself. Listen to the shortcut but use the same interface to go out. Right? Done? That is all I have to do. Which one? This? The shortcut. See, he will only listen to the shortcut if he gets a redirect. I have configured this interface right here, this DVTI, to give out the redirects. So the redirects will be given out from here and from here. Right? I've told him to send the shortcut where? To this. And I've told him to send the shortcut to this. But he also, it's a redirect coming here. He also has to listen to that shortcut. Right? So I have to manually tell him, hey, the shortcut you take, but take it from the same interface which you're creating right now. I'm not guiding it to throw it out somewhere else. Telling it take the shortcut, but take it through this interface. Which interface? Template 10, which is himself. Here. Right? So that redirect that he receives, he will take it and go this way. The same thing will happen on this side.
Without IP NHRP shortcut, only with IP NHRP shortcut also it will work, I think.
IP and HRP shortcut will work. Why? Because it worked in DMVPN. But on a virtual template, you have to specify it this way.
But we already specified over there, no?
We specified it to come here. Right? We can work it. Yeah, we'll try the next time. Once we get this working, we'll remove this and we'll see if it works. Because probably what happens with IP and HRP on a virtual interface, on virtual template, you have to provide which side to go out. But yeah, shortcut should work like we worked it where? In the DMVPN. Okay? This is all I have to do for the VTI. Everything else will be received from NHRP. The resolution request. Okay? Let's try. Let's copy this. Do I have the same thing on both sides? I have the same thing on both sides. Same tunnel 0. Same virtual template 10. And same network ID 10. Copy. First on R3. Just to make sure that I have not specified a virtual interface before. I'll check it. No virtual template. Right? So it's alright. Copied half of it, is it? What did I do with the shortcut? Did I specify template 1 or template 2? Template 10. Yeah, that's good. So this is fine. Crypto this, virtual template 10, interface virtual template 10, all of this, and it's all good. Right now it's down because I need to send a redirect first. And I'll need to create the other side also. The other side he tried to create a tunnel, but he could not because I had not done it here. Also 10. Copy and paste. Done. Virtual template is done. Right now, check this. My routing protocols tells me that 10.3 is through this. Let me trace route. The first packet is going in here. Right now when this is happening, my virtual template should be solved, which is not. Yeah, there you go. Virtual access is turned up.
Yes.
So my neighbor is also come up. Why? Because my virtual access is now connected from where? Directly from 11 to 12. A big tunnel was created from spoke to spoke. If you check your IP route, this now is from where? 11. It was from 1 before. It was from 1 before, but now it's from 11. Right? So this
Percentage sign is showing this because of this virtual address.
override.
Why still
Override. But it's still going this way. It's still going this way. I know why this is.
routing.
Not routing. The NHRP is not getting resolved like it should be.
There's no mapping.
No, I'll have to do one more thing. I'll show you what.
Redirect is enabled.
Redirect is enabled. No, that's not the problem. I know what the problem is. I have to override my user. 10.4 is going direct. 10.4 is going direct, right? Why? He has 10.4 through which guy? So spoke to spoke is working one way, but this way it's not. 10.3 is not going direct.
So what about that command of no next stop
IP next stop self? IP next stop self? No, that you would use if you have one interface, MGR. MGR is one interface on one side connecting to all. Here you have different virtual templates, one going here, one going here, and all the others going there. No, you can't. Show IP and HRP. I am actually getting some maps here. I'm actually getting some maps. 10.3 is incomplete. He has not created 10.3. There is the complete one. His NVMe address is
Okay. We need to clear up.
this one. No, it should work. Clear IP and HRP. Clear crypto sessions. Let's create the whole sessions. Clear the whole sessions. Then go to my tunnel. Shut. Let it go down. And no shut. Okay, it's coming up. He should create a neighbor relationship pretty soon. One is up. Show IP route. I have this guy. Right now, no NHRP mappings.
Yes.
So trace route 10.3.3.3 source loopback 0. First should go this way. Virtual 10 interface is up. He should create a neighbor very soon. The neighbor is also up, and he's going direct. Okay, there was a problem with the first mapping. It was incomplete.
This is in R4, R3. The
On
port is
R4.
in R3.
R4. R3 will be the same. R3 will be the same. It's going direct.
Okay. So that was the NHRP one.
That was the mapping was incomplete for the first one. It's going spoke to spoke with through what? Through this tunnel. Let me explain to you how this NHRP works. The thing right now, if you look at it, right now there is no NHS. You don't have any NHS. How does he resolve these mappings? That is the question. If you check his mappings, he has the mappings for what? 12, 10.3 and 13. How does he get these mappings? Who gives it to him?
The pool.
No, not the pool. Not the pool. Look at how the communication takes place. I'm going to clear this and I'm going to definitely save. Flex. This is spoke to spoke. Check this out. This is my server. I will not create the internet in the middle because I've been doing that a lot today. This is R1. The internet. R3 and R4. The address here is 192.168.11. The address here is, but I think when I refresh the tunnel it was changed. Yeah, so this side is 13. This side is 13. Right? When my virtual when I ping, this has a loop back off and this has a loop back off. I ping from here. What does my packet look like? Source is 10 3 3 3. Destination is 4.4.4. Right now he only has one tunnel, this one, right? That is the only one tunnel he has, so he has no option but to send it through the tunnel. That's how we saw the first ping goes to 1.1. The first time I trace route, it goes to 1.1, right? So the whatever is going to be here is ESP, and then the outside header is going to be 192.168.1.11 to 1 dot. Can't we undo?
Control Z to control Z.
No, does not work with Epic. It's too epic today. So again, R1 quickly, R2, R3,
R3, R4.
4, 3, 192.168.1.11, 13, 10.3.3.3, 10.4.4. and the packet looks like this, from going to ESP, this one, and this is the source is not actually this is not the source. The outside source is going to be 23.3 with the destination as 12 dot going from here to here. Why this? Because the next hop is going to be 192.168. If you check for now, he won't show you. The next hop is, say, for 1.1 is 192.168 1.1. So the first time this one was also 1.1. Now he changed it to 13. But when I didn't do that trace route in the first packet, this was 1.1. So he knew he was supposed to go through the virtual access. The outside header that he puts is this for the virtual access. And the packet reaches whom? This guy. Right? R1 has to make a routing decision. Based on whom? These two. When he makes the routing decision based on these two, he checks where is 10.4. Let's go to R1. He checks where is 10.4. He sees 10.4 is through 192.1.13. He checks the source. He sees the source is also 1.13. He realizes both of them are on the same network. That is all he realizes. He realizes one is 1.11, the other is 1.13. He does forward the packet. But while he's forwarding the packet, he also forwards something else. Not forwards, sends. What is that he sends? Redirect message. A redirect. Redirect saying, if you want to go to 10.4, you go to 192.168.1.13. And for him, you tell him, if you want to go to 10.3.3.3, you go through 1.11. He tells him that. It's an NHRP redirect message. So what this message comes where? To this guy. To these guys. Right? Now he needs to create what? That virtual access here. But this resolution request, now this guy came in with this redirect message. He needs to reply with the resolution message. That resolution message is not sent straight here. No. That resolution message, say this green is my NHRP resolution message, is sent through this tunnel to the hub. The hub forwards it to this guy. This was a correction in DMVPN. The hub does not resolve these requests. The hub does not resolve it. He actually takes the request and forwards it to whom? This guy. In the request, he's basically telling him, hey, listen, I know you are 192.168.1.13, right? This is my source. In the request, there is a source. He's telling him my source is, my NBMA address is 12.1. I want to know what your address is, your NBMA address. Tells him I want to know what your NBMA address is. For him to create this one tunnel, what does he require? A source and a destination. That's all he needs, right? To create this DVTI. Does he have the source now? Sorry, the destination. He has the destination now. Does he have a source? He has the public source as his source. Destination was received by an HRP resolution request. Right? He doesn't even throw it this way. This guy also sends him a resolution request this way. Comes to this guy saying, hey, listen, I am 1.13. My NBMA address is 24.4. What is your address? To reply to this resolution request, they don't go through the hub now. To reply to this resolution request, they create this tunnel. Now they have the source and destination from their side. In the meantime, the other guy also receives it. He has the source and destination also. So they negotiate this tunnel here with all the IKE initial message and IKE auth message is exchanged over here. Why? Because the source and destination is known here. The source and destination is known here. So he replies to him saying, hey, my destination address is this, through the tunnel. And he replies saying, my destination is this, through the tunnel. When the tunnel is set up, they don't need anything else. Why? Because the virtual access automatically has the source and destination. The public source becomes, from here 23.3, from here it's, how did he know the destination is 23.3? This NHRP resolution request. How did he know it's 24.4? This NHRP resolution. So he knows to go, now he knows that if I want to go to 10, now they don't need to exchange 10.3 or 10.4. Why? Because they have a neighbor relationship. The tunnel source address from here is 192.1.13. From here the source is 11. I have done EIGRP. My EIGRP is running over here. So these networks will now be shared over whom? This one interface. So they don't need the hub anymore. They are directly neighbors with R3 and R4. Is this clear? Any questions with the NHRP? If R1 goes down, everything goes down. This tunnel will go down, this tunnel will go down. If this is up, he will stay up. This will stay up for that amount of time until he has the NHRP mappings.
That is again 16.
What? NHRP is 2 hours. 2 hours, you can see it here. Not here. R1 doesn't have anything. R1's NHRP is empty. He does not store any data. He just forwards requests from here, forwards requests from here. Only data which you have is on R3 and R4. 10.3 is through the tunnel. 192.168 is through 192.168.1.13, which is directly connected to me through the tunnel, and the NBMA address is 24.4. Is this clear? This is myself for 10.3. This is a mapping for myself. 192.1.23.3 is myself. So if he wants to ping himself, right? From R4 also he will have a NHRP mapping for 10.3. The time is 147 through 192.168 1.11. 1.11 is his neighbor. 1.11 is a neighbor through where? Virtual interface 1. Whole time and everything is given. So he has a direct relationship with the spoke. That is your DMVPN summed up as Flex. It's flexible. Why? Because remember R1, I did not do a lot of things on R1. If you compare this R1 to the R1 in the previous lab, only one thing I added was the pool. That's all. And obviously NHRP. I just have to make R1 part of NHRP. The decision is made by him when he has to forward traffic, and he knows that forwarding traffic, both of them are part of the same NHRP domain. He knows this guy is also part of my same NHRP domain. This guy is also part of the same NHRP domain. Why don't they talk directly? If they are in the same network, why don't they talk directly? So he just tells him, hey, listen, he's in your same network. He tells him, hey, this is in your same network. He doesn't tell him, he just sends a redirect saying, hey, go directly. They don't know how to go direct, so they go through the hub for the resolution, and he goes through the hub for the resolution. They get their NBMA addresses, create a tunnel.
So that redirect command,
Yeah.
10.4.4, this is, he said that 1.13.
1.13.
Through that IP table or
He has that through his routing table right here.
through his routing table?
Through his routing table.
Because before it was through NSRP table.
Yeah, no, before also. That's what I wanted to clarify. Last time what we did, this thing that we did last time, there's a correction in there. That at that time also it happens the same way.
So IP table.
Through IP table. Through the IP routing table. At that time what I had said was R1 resolves everything for them. They send their NHRP resolutions to R1 and R1 resolves it for them. But that's not the case. That time also he gets the request from this side. He checks the source and destination. If they are on the same network, the final networks are the same. It's coming from 192.1. One endpoint of the tunnel is 192.168.1.11. The other endpoint is 192.168.1.13. They know they are. He knows that in the same network. So he says, all right, if they are in the same network and the domain is also the same, they need a redirect. So he sends out a redirect to them. And they don't talk to the hub. Their request, the destination is .13. And for him, the destination is .11. But it's going through the hub. Because at that time, they don't know what is the direct address, the NVMe address. In DMVPN, he doesn't create a tunnel back. The NHRP reply comes back through the hub also. Here the resolution reply does not come back through the hub. Here he creates that virtual access and replies through that. Because they both have everything that they need by that time. So by the time NHRP is resolved, virtual access is also created. And then obviously you have routing enabled and the traffic goes through that and creates a neighbor.
Since there is a direct communication between both the scope,
Now there is, yeah.
so that's why in the routing table it's showing the overridden.
Overridden, that's why, because now, see. This is overridden. To whom? Why? Because this static route was installed where? Route set interface, install this. Route set installs this route. If you see, this is next hop is override. Why? Because from R3, this is what? 13. What is my address? My address is 11. Right, so this, he has it as an EIGRP neighbor. He has this guy as the EIGRP neighbor. He can go there directly. He can go there directly. Why? It is a next hop for him. So he does not need this in the routing table. He was installed as a static route, but it's overridden. Why? Because now it's directly connected to me. So I override it. I don't use this one. This one is not used anymore. Override means override this. Why? Because it's directly connected to me from the other side through that virtual access. It's directly connected now. Show interface virtual access. Can we move this? No, right? Huh? Hide link will hide this. Oh yeah, nice. So this is my tunnel 0. My endpoint is this, and I have this right here. Right? Source and destination is given by whom? The NHRP. NHRP told me the other side is this, and that side also he told me the other side. Is this clear? Any questions? This is the most difficult part of Flex. That is all.
And in this, what I read was the request goes to the hub. Hub replies with the destination to
With the destination to?
the request, and then request goes to direct to that.
The request goes, let's see, I have the Cisco docs right here.
Because you cannot change the packet.
Who?
Source and destination.
The source and destination. Flex, spoke, to spoke. Yeah. There's a whole packet exchange that is explained in these docs. So we'll see that. This is the exchange. Right? This is the description of the exchange. This is your host request. Host request goes to the hub, goes to the other side. In the meantime, what this hub does is send a redirect, send a redirect. Then the NHRP resolution request goes where? Straight to the other spoke, right? The resolution request from the other spoke comes straight. Then the IKE is formed between spokes. Nothing is done with the hub. See, hub is not, the only thing the hub is doing is sending the redirect on both sides.
This is like forwarding.
Just forwarding the request. This NHRP request is also forwarded from this side also, even from this side. The moment he receives the resolution, then the reply does not come straight, it's through the IKE initialization. Clear?
So that means he only replies with the destination.
Who?
And then the hub replies
In the redirect. That's what he does in the redirect.
Again, a new packet is generated for request and directly goes to the.
This one, right? The resolution. NH resolution request is a separate packet. That's what I showed you here. How do you get back? That's what I said here. See, this was a redirect coming in. This resolution green one was a resolution request.
The resolution request is it's not forwarded.
It's not?
Forwarded.
It goes straight, yeah, it goes through the hub. Why did I say forwarded? Because it leaves this interface, is this virtual access, then it goes out from the other virtual access.
That's what I am saying. The request goes to R1.
This
R1
request.
replies with the destination to R3 again.
R3 again.
Yes. And then R3.
R3 goes straight. But that's not what he shows here, see?
Chrome needs
ये वाला.
Chrome again.
Again Chrome. Check right here. This resolution request. Is the hub replying with anything to him? The request which I'm sending from here, is the hub replying? He's not. It's the same like this packet which was going through, is the same like that packet going on. But now inside the packet, it's a resolution request with the information about my source. Because he knows, the host knows that who's going to take me to the other side? The hub. So he sends it to the hub here. Then see, otherwise he would show you hub sending something back and then he creates another packet to send back. Right? So then another resolution request goes out from here. But from here, only one resolution request is going. And from here also, only one resolution request is coming. From R3 coming to R1, but through the hub. It's called spoke, hub, spoke. The communication is called spoke, hub, spoke. It's not meant for the hub. The destination is the spoke. But the way, the path to go through is through the hub. The hub does not do anything. His destination, when he opens the packet, he sees the destination is the other spoke. So he doesn't do anything. He knows it's an NHRP request. He just forwards it from the other virtual interface. Only the redirect is sent to the spokes. That's the only thing that he does.
When is the redirection after the command?
The redirection is?
Yes, the redirect messages are sent.
It's sent, see, the first traffic goes in. The moment the first traffic goes in, then the hub can, at the same time the hub realizes. When he makes the routing decision, he realizes that both of them are in the same network. Once he forwards it, he says, all right, if they are in the same network, let me send them a redirect. So he sends
There are
this
two
redirect.
packets sent over there.
Which one?
In first two. After NHRP redirect, there is one more packet.
No, you know what that one is? Excuse me. You know what that one is? See, this was the first packet sent. To that packet, this was the reply. That is the reply which is going. Because the first ping completes, right? How will the first ping complete? When it comes back. This is the echo request. And this is the echo reply. Now he's cutting off here. Why? Because first he sends a redirect and then he replies with the. So this is the one which he gets back. Check, this is what the host receives. The first he receives is this, right? Then he sends the redirect. The host is not sending the redirect. This guy is. The only packets leaving him is this one. Right? This is your spoke. The only one packet leaving him is this. The only one packet receiving is the request from the other spoke.
Yes.
From the other spoke. What you're saying is the DMVPN in the first one. Why? Because the spoke at that time, the hub has all the mappings.
Yes.
Here the hub does not have anything.
Yes.
He has no mappings. Yeah. Here he does not have any mappings, so he does not know what to do with it. He does not reply with the mappings.
Right.
What you're saying is DMVPN.
In that case, yes.
In that case, he replies with the mappings, then they talks direct for the resolution. Here it's straight through the hub.
In that case, it was sending only destination and then they were coming.
Because the hub had everything else.
Yes, yes. Okay.
Here the hub does not. I showed you the NHRP table on the hub. It was empty.
Yes.
Okay? Any questions? Any more questions? Is this clear? The communication between the hub and spoke. The spoke to spoke communication. Is this clear how this is happening? The redirect and everything? This is plain Cisco docs. Okay? That is how your flex spoke to spoke works. The only one thing that's left right now is server and client. Very subtle differences between the two. Very subtle differences. But I will not do it today. I want you to do this today. So we'll do that tomorrow. It'll be a recap of everything from flex beginning until the end.
So just 2 steps.
Just 2 more steps, but we'll be repeating all of this.
Tomorrow.
So all those fill in the blanks that are left in our heads will be cleared one step at a time. And then we'll also do the theory of SSL VPN. Okay?